Today topic is work energy power. So in that, first today we are going to discuss about the introduction of work. Okay, so we know that the basic definition of work is the product of force and displacement is called work. So let us see the diagram. See, this is the object of mass m which is placed on the horizontal surface. Okay, now if I apply some external force here, so due to this external force, definitely this object moves some displacement s bar. So force is acting, at the same time the object also moves with some displacement s. The product of force and displacement is called work done. So that is the definition already I told. So coming to the formula, work done is nothing but the product of force into displacement. So we know that force symbol is F bar into displacement means S bar. So work done W is equal to F bar dot S bar. Okay, so this is the formula of force. Now coming to the units. So we know that SI unit of force is Newton and SI unit of displacement is meter. So coming to the unit, 1 joule is equal to 1 Newton meter. Okay. Now the dimensional formula is W is equal to force into displacement. According to Newton's second law, force means mass into acceleration into the displacement as it is I wrote. Okay. So mass dimensional formula is m. Acceleration dimensional formula is velocity by time. So L t power minus 2 into displacement means it's a type of length. So we can write it as L. So m as it is I wrote L into L square t power minus 2. Okay, so this is the dimensional formula of work done. Okay, and the last point is work is a scalar quantity. Work is a scalar quantity. Okay, so this work actually classified into 3 types. So we will discuss one by one. The first one is a positive work. Let us see. So this is the object of mass m which is placed on the horizontal surface. So in first case, my applied force is acting in this direction with some angle theta with respect to horizontal surface. So whenever force is acting in this direction, due to this force, the object covers some displacement along with the direction of the force actually, and it makes some angle theta. Okay, so we know that the resolution of vector and this force vector makes an angle theta. So horizontal component is cos component with respect to this vector. So horizontal component is f cos theta and perpendicular component is f sin theta. So I didn't mention here, no need. Okay. So this force vector makes an angle theta, that is f cos theta, along with the direction of the displacement. So work done is equal to f cos theta into s. Okay. Suppose, let us assume here the angle of inclination or angle is theta is equal to 60 degree. I am going to substitute here W is equal to Fs cos 60. Cos 60 value how much? 1 by 2. That is we know clearly. So Fs into 1 by 2, that is nothing but Fs by 2. Suppose theta is equal to 30 degree. Then W is equal to Fs cos 30. Cos 30 value is root 3 by 2. So you will get work done is equal to Fs root 3 by 2. Okay. If it is theta is equal to 45 degree means you will get Fs by root 2. So whatever it may be that, I mentioned the point. If theta value lies 0 to less than 90 degree, I mentioned clearly less than 90 degrees, then the work done always positive. So here you got a positive, and for 45 degrees also you will get for positive work done, and for 60 degree also you will get positive work done. Okay. The best example is all freely falling bodies are the best examples of positive work done. How? Whenever an object falls freely, the force acting in downward direction and the displacement also same direction, in that case theta value is equal to 0 degree, cos 0 is 1, so work done is Fs. Okay. Now coming to the second type, that is zero work done. So already I drawn the diagram here. So this is the object which is located on the horizontal surface. So in second case, my applied force is acting in upward direction. So due to this force, the object covers the displacement along horizontal direction. See here, force is perpendicularly upward and displacement is along horizontal. What is the angle here? Exactly 90 degrees, right? So theta value is 90 degrees. We know that work done formula W is equal to Fs cos theta. Theta value is 90 degree. So W is equal to Fs cos 90. Cos 90 value is 0. So work done is 0. The best examples is pushing a wall. So if you apply some external force on the wall doesn't move, right? So in that case, displacement is 0, even though if you applied a large force, the wall doesn't move, right? So that is one example. And the second example is an object revolving in a circular track. So whenever an object is revolving in a circular track like this, see, this is the initial position of the object and the object is moving like anti-clockwise direction and finally reaches the same position. So for one complete revolution means displacement is 0, right? So the product of force into 0 means you will get a 0 work done. Okay. So coming to the third type, that is negative work. So I have an object of mass m which is placed on the horizontal surface, right? Here my applied force is acting in backward direction. So due to this external force, still the object is moving forward direction. That means force is negative x-axis direction, displacement is positive x-axis direction. So what is the angle between force and displacement here? Theta value is 180 degree because force and displacement are anti-parallel, right? So theta value is 180 degrees. So work done formula Fs cos theta. So Fs cos 180. Cos 180 value is -1. So work done is minus Fs. So for this, best example is walking a person on the road. So whenever a person walking on the road, he is going to apply some force on the horizontal surface or the road in backward direction. At the same time, he is moving forward direction. That means the displacement is forward direction, applied force is backward direction. So angle between force and displacement is 180 degree. So work is negative. Okay. So I hope you understand. Thank you. Thank you so much.